All right, so here's number 12 from this problem set. We have g of x equals e to the negative x. They've written this as an inequality, and so I've written it as an interval. However, I've written it incorrectly because they had inequalities and I wrote an open interval. It's actually a closed interval now that I look at it more carefully. All right, so remember the process. So the process here is find the critical points, find the endpoints, and then do your first derivative test on your critical points, and then compare your endpoints. All right, so first we're going to find critical points. So step one is find critical points. All right, so our function is g of x equals e to the negative x. So the derivative of that is g prime of x equals negative e to the negative x. This is a chain rule, you can check it out. So I want to see where this is equal to 0. All right, so sometimes when we're looking for critical points, it's easier to take our derivative and write it as a fraction. So this is also could be written as negative 1 over e to the x, right? Then I can look at where, see I'm breaking this down the same way every time. F prime of x equals 0, and where is f prime of x undefined? All right, f prime of x is 0 when the numerator is equal to 0. Our numerator is negative 1, and that's never equal to 0, so that has no solution. So there's going to be no critical points there. All right, what about where f prime of x is undefined? Well, then I would put the denominator equals 0, e to the x equals 0. As we have now observed several times, e to the x is always positive. E to the x can never equal 0. So it follows that this also has no solution. All right, so this function has no critical points, which, by the way, if you think about what this function looks like, of course it has no critical points. It looks like that. So it doesn't have any relative maxes or mins. So the only place that there could be a max or min, and there has to be a max or min, because the continuous function, it's a closed interval, there have to be max and mins. So those critical points, those maxes and mins must occur at the end points. All right, so step one is we find the critical points. Step two would be we would analyze the critical points if we had any, but we don't. So for our step two, we're going to look at the end points. So it's really important when you're looking for a max or min on an interval that you look at the critical points and the end points. Those are sort of the two main categories of things that you're going to look at. So for our endpoints, I have x equals negative 1, because it's closed on both sides. So I have two endpoints this time, x equals negative 1, x equals 1. All right, so then what is f of x? F of negative 1 is equal to e to the 1, it's just e. What is f of 1? It's e to the negative 1, so that's 1 over e. All right, so what I need to know is that 1 over e is less than e. All right, 1 over e is less than e. So the point negative 1e is the max, and the point 1 over e is the min. So these maxes and mins are absolute on the interval. All right, on the interval negative 1 to 1. Of course, they're really relative to the whole real line, but on that interval, they're absolute max and mins. As you look at what's happening really in the graph there, well, on this graph here, okay, you have e to the x doing this, all right, and here's the point negative 1e, and here's the point 1 over e. Max, min. Okay, the next problem is significantly more difficult, so hopefully I will have time to look at it, but I think I'll take the opportunity right now to tell you that your homework assignment on this is going to be this same page. It really starts on page 193. All these problems that I've shown you on page 194, it really starts on page 193. And we're just going to do 1 through 27 odd. All right, and you could theoretically just go ahead and start on those and not watch the next couple of videos, because I'm just going to go through some more examples of even problems. If you think you've got it, go ahead and do it. My next example will be pretty good to look at, though, because it's pretty difficult.